It is January 18th, and it is time for another libhal weekly meeting. Now, I am very excited for this week. There's been a buttload of changes, like a large number of changes. A lot of them inspired by my collaboration with the SJSU robotics team. To also bring this up, this actually isn't listed here, but we started transitioning them over to libhal from SJSU Dev 2. I'm very excited with the progress that I'm seeing. I'm very excited to see and get a lot of feedback about things that should be changed and things that are hard to deal with and that kind of thing. So it's all been super helpful. Not everything's gonna be listed here. I think some of the items that I'm considering in my head that I've gotten as feedback or things that I've just observed that I think may need to change. Um, I may come up with solutions for next week, and I can talk about those later. So our agenda today is I'm going to go over a live project demonstration, showing you just how to start a project, how to install libhal as a developer, and how to use it or get all the tools necessary to do it. I'm also going to go over the repo name changes. We had quite a few of them. We had people vote on it. We got 6 thumbs up, so that was great. I'm going to talk about how we are packaging up linker scripts as well as toolchain files, or packaging up our linker scripts so that we no longer need to copy and paste them around, removing the need to install the toolchain. By that I mean the compiler, finding places for the toolchain CMake file, which is another file you have to just copy around in order to use it for your project. Using target library components in order to simplify your build code, like to a dramatic degree. And then finally, some updates to the documentation. So let's get started with the project demonstration. I love this. So I forgot to add a link, which made my life a little easier, but don't worry, it shouldn't be as hard. I'm gonna add that link later on. So we're gonna go to, install prerequisites. So actually, here's the new documentation if you haven't seen it already. I've been simplifying some things, writing some things around. I'm probably gonna change this little area here to something even simpler than what we have here. Because it's like for actually doing multi-device type stuff. But yeah, so let's just go over to install prerequisites. So I'm going to run through the installation steps through here, but the way I'm going to do this is I'm going to go to libhal starter. This is our starter project. It has the minimum required in order to basically build a project. The git ignore is just something that we have for, you don't really need it, but you can use it if you like. But yeah, only 1, 2, 3, 4, 5 files that you actually need. These 2 are not necessary. So if you have a GitHub account, which everyone here should, you can click on this. You can go to open in code space. And here you'll have a VM of that particular repo in that particular branch available for you. So you can start coding directly into the browser. I kind of wish we had web serial, like I could add some type of web serial plugin for this so I can basically run my Python installers or Flash programs through this. But maybe I'm not sure how you make that work, but that would be a really cool thing if we could do that. I actually already have an idea. I do have an idea in my head. Beside the point. Okay. Alrighty. I don't know why that ls is... Okay. So things are still loading. Alright, so now we have a code space. And this is just to represent if I had a completely new, fresh computer. In this case, it's Linux. But I just want to make it very clear. The installation steps are very simple for all platforms. For Ubuntu, it's just simply running this, which we don't have to do because this code space already has the latest... already has G++11. But then after you run that command, you then run the Python command. Next, got a couple commands for Mac, a couple homebrew installs, install with Python, and then you want to install Rosetta so you can actually use the tool chain. And then finally, there's this program called Choco for Chocolatey. This is the command to install Chocolatey onto, you open a PowerShell, run that, it'll install Chocolatey. And then you can install Python this way. You can install MinGW, which gives you GCC 11, and then you can also install your code and CMake stuff. Very simple, very quick. And to actually show you this, I'm going to do it right here. So I'm actually going to start a little timer. I want to see how long this actually takes for me to do. So let's get up a timer real quick. Actually, no, I'll just do a timer or stopwatch. All right, start. Okay, let's do this. So first things first, allow, install. Let's get that going. Okay, all right, good. While that's going, okay, that's done. Let's move a little lower. All right, so we got Conan set up. We want to set up the default. We need to create a default profile. It's just basically profiling your computer to know what things are available, And then after you create the default one, you can actually set it to the appropriate value. So in this case, I'm using Linux. Windows would be the same thing for GC11. You just copy and paste that. Keep forgetting that that's the wrong spot. Paste that. Do not ask again. All right, that should set us up. And then lastly, we need to set up the libhal trunk repository. This is so we get the latest and greatest packages. All right, so that pretty much was successful. Remote registry file missing, created a default one, and then I added in the revisions enabled, so that's good. Make sure we're still recording, great. Awesome. All right, so that's it. All the tools required for libhal and all the setup is done. So that's all you had to do. I don't even know how long that's been, 3 minutes. Okay, so let's see how long it'll take us to actually clone down a starter project and start going from there. So I don't need to clone, I've already cloned, so I can skip this step. And actually what I want to do is, well, so there's some compiling steps here, which are basically on the bottom. I can also go to libhal starter to find the steps as well. There'll be in both spots. I want to make sure that when we're developing, and I'm still keeping the time going. Oh, is it going down? Oh, okay. Oh, is it doing both? Weird. All right, so it's only been a minute actually, so I'm incorrect. Cool, awesome. Oh, it goes back. Weird. Okay, whatever. So yeah, let's go in here. So we just need to make a build directory. Go into build. All right, very good. And then from here we just got to run Conan install -s, setting the setting of build type to debug, and then setting the build to missing. This will ensure that we actually build any particular packages that do not have a cached version of their binaries for our particular system. That's all to say is that like whenever you build a Conan package, if you want to, you can actually package up and save all the binaries that were generated. Now, most of our stuff is header only, but the ARM compiler is its own big, gigantic thing. So because of that, I don't want to cache every single version for every single version of Mac, every single version of Linux. I think those should be installed and downloaded directly from, well, GitHub. And I'll talk about how that's been done, or how that works in a little bit. Right now, this is actually handling installing the ARM GNU toolchain, the GCC for ARM compiler. You don't have to do this by hand. This will set it up for you within Conan. You do have to use Conan in order to get access to it, although technically, if you wanted to use the same files, you could add a path to that location if you wanted to. Right now, it's extracting the tar.xz file. We gotta wait for that to finish up. But yeah, this is kind of, let's see what we got here. Let's reset this guy. I don't know. Stop. Yeah. I do not want you. I want my stop. I want this guy. If I go away, will it stay? Yes, it will stay. Cool. All right. So let's see where we're at right now. It's still extracting. It's only 3 minutes. Let's see if we can. I'm hoping to get under 5. My what I've been trying to tell people. What I've been telling people is that it should be under 5. It really depends on how good your internet speed is and how fast your thing can extract these files. I wonder if there's a way to do this in parallel, because I feel like this is a little bit slow, but we'll give this thing more time as it writes in. And while we're waiting, what we can do is I can kind of explore some of these files here. I'm just gonna knock this one out. This is the newlib file that just specifies all the low-level APIs that the C library calls. This is just here to get the compiler to shut up, because it will yell at you saying, "Oh, warning, these things aren't defined." It should actually define those itself, but for some reason, the new ARM compiler doesn't do that for you. That might be a bug. It might actually be a feature. All I know is that we have this new libcpp file just to get rid of that. It will not cause your program to not compile so long as you're not actually using any of these APIs. All right, so that's pretty much finished up. It'll probably download and install the last bits of our dependencies. If I go over here, we have our main program. Nothing too crazy. Let me fix this swiggles problem. I always forget where the location is. Let's add a new tab here. You're gonna give me a shell? Give me a shell, please. There we go. I think it's a little busy right now, given cool. All right, so actually let's do pwd/workspaces. Actually, let's go into Conan and do pwd there. Cool, so home, code spaces, Conan. If I go over here, this might actually help everyone else too. If you use the absolute path, I think that fixes it. Fixes it in this situation. So if I just kind of do that and then do this, I should be able to control click on these and boom, there they are. So no more error messages here. So we have that. Let's see if this one's still doing Python 3, so it's still loading up stuff. So I'll let that do its thing. We were at 5 minutes, unfortunate. Just takes a little bit of time for those files to extract. Hey, who knows how busy these VMs are? So here we just have a little section here for initializing the data section. Then we initialize the floating point unit. Right now, this particular project is set up for LPC 4078, which has an FPU. So we have that there. We grab our clock. We pass the clock information. We get the actual frequency, pass it into our steady clock, our DWT counter. We get pin 1, pin on port 1, pin 10. And then we just blink it high, blink it low, and delay in between. That's pretty much it. Let's see if this is, oh, that one's finished. So we are nearly done. We are at 6 minutes. Let's see if we can make up some time, or not make up some time, but see if we can get this through this as quickly as possible. So we got to run this Conan program. We paste that in, enter. That will install all of our, I'm sorry, I already did that. I don't know why I did that again. That's where we got all the installation stuff happening. All right, so now we have to run CMake. This will generate our make programs. So right here, done. All right, and then make-j. J just means you go multi-threaded, and boom, there you go. That binary right there. If I were to extract it, literally, copy and paste it out from here and download it onto my computer, and then flash it onto an SJ2 board or the Micromod LPC 4078, that'll work. It'll legitimately just work. You'll see a blinker. That is pretty much all that you need in order to get this thing done. So I would say around about 7 minutes in order to get this thing done. Your mileage may vary because most of the time we spent was mostly waiting for ARM-GCC to install. But besides that, the steps here are, in my opinion, and I hope everyone else agrees, quite simple when it comes to getting set up. And here we have a little blinker. So that's what this is. That's how the new setup is. And I also wanted to show you how few lines of code there is. So in this case, we have 44. You have a couple of things in here that are explained. I think I explained most of it. Oh, I'm still writing it. Okay, it's still in a branch I haven't pushed yet. But I'm explaining all the different parts within this project so that it's known why we do certain things. Some parts in here, though, are listed inside of the target library. We'll go into that later. But I want you to just see what's required inside the Conan file. We have requires our only library, which is libhal LPC40XX 3.5. Then we have a couple of tools that we require. One of them is the tool chain, literally the compiler that we're using. We can require that as its own Conan package. We can also require the CMake thing that we use for getting the tool chain file, which is used to tell CMake how to use a different compiler. We have that defined here. And then we have to specify some generators, basically things that we say, we want you to take the Conan files, we want you to generate CMake toolchain and CMake dependency files. That way we can use CMake for our project. And just look at the CMake here. It is basically 8 lines. If I remove these little spaces here, it's 8 lines of code for the entire thing. If you've always been concerned about, if you've ever seen CMake before and you've been concerned about how ugly it looks and how crazy it can look, right here, this is pretty much the pinnacle of modern CMake. If I'm package command versus use external or something like that, it's a really simple list of your executables. Using the standard compiler features without specifying like the direct std equals C++20, which may not be cross-platform for different compilers. Just adding your current directory, adding your specific target that you're trying to program for, or the libraries that you want to bring in, and then some post-build stuff. That's it. 8 lines. I took a good, I think around 3 weeks to try to get everything trimmed down to this level so that you get a properly sized program. Actually, I'm going to do one more thing. I'm going to do Conan install. There we go. No, I don't want to do that again with debug. I want to do release. Oh yeah, this server is a little laggy. Cool. And then I want to do CMake. And then I actually want to do, I think I might have to remove that might have worked. Let's find out. If it's a small number, there we go. Our little blinker here is about 5K. Now, I believe if I did a busy wait rather than doing actually using the DWT timer, I could probably get this guy even smaller, but that's a pretty small amount of space just to get a little blinker going and get all the other infrastructure you need to get things running. Before up here is around, what was the number? The number was 29 or 26K. So pretty big difference. So yeah, that's pretty much it. So that was the first part I wanted to show you, was just how to get started with libhal. Is now been a very simple process. I would recommend that if you're trying out libhal, I recommend you just go through the steps. So first it's install prerequisites. I recommend reading the glossary just so you have an idea of what all the different terms are as we explain them any part in the documentation. Then next is just trying things out. This would be an example that goes through using libLPC and like cloning from the I need to change the name here. That should actually still work because I believe Git will remember old names that you've used, old aliases. But yeah, that is a issue. So I'll have to fix that. Same thing with libstm, although that one has not been changed. You actually cannot use this example, so I would not recommend it. There's nothing there yet. But this one does work. Then you just go through these steps. It'll tell you how to do every little bit of how to program and develop things. It also shows you how to actually program the stuff. And there you go. You should be able to run the UART example on an SJ2 board using this command with changing this particular element, this particular argument here. And yeah, and there's a lot more to the documentation here. We have some information about the organization, although this is still pending. There's nothing in error handling yet. There's nothing in on-chip software design. There's only a little bit of information on the ADC library here. I think maybe some of the other ones have some other stuff. Yeah, but they're not complete yet. Still working on those. I'm only one person. All these other ones are pretty much blank. If you haven't read the design philosophy, please go ahead and read it. It's really good and useful to know. I'm actually going to change this one from simple to minimal because I think that represents what this particular design philosophy is. Simple is a weird word for a design philosophy, but I think minimalist is a better way to define what I want for this project. And you can see all the different architectural design decisions that are here and made. And they will probably color more of your opinion on like, oh, this is why we did certain things. This is why it looks this way. There's a lot of content here that I've written in here. So I recommend you go through and read through that if you are interested. Also the style guide explains all the different little bits and pieces. There's more to be added to this, but this is what we have now. And yeah, that's where the documentation currently lands and where it currently is. Yeah. So that is the little tour of libhal. The link is right here. It's just libhal.github.io in order to get into the documentation and really go from there. So let's go back. All right, so let's go over a couple name changes. So repo names that change. liblpc40xx is now libhal-lpc40xx. Basically, all of them where it said lib turned into libhal-. Why? Well, these three reasons. This change makes it easier for finding the libhal official or just whatever libraries are using libhal easier in the Content Center. So if you just type in libhal- or just libhal in the Content Center, once we start putting things up there, you'll be able to find all of our different libraries. So it'll make it quite easy for people to search for them. It's easier to read. Yeah, just having that dash is a little easier to read. I'm still going to try to keep with the previous system, which is snake case, no spaces, no indent, no separation, unless it was required. But yeah, I think this is nicer and easier to read. And then also less arrogant. That was trying to figure out the right word for this, but I think arrogance is the biggest one. I think this is going to sound a little bit rude to this individual, but like when I found out about build 2 and I saw that the build command was literally the letter B, I thought, wow, that is some arrogance there. You just took the entire letter B as your command for build and kind of search yourself, yeah, I am the build program. I am the build program. Actually, I think even his documentation says I want to be the last stop shop when it comes to build systems for C++. And I love that energy so much that I made all my libraries like this. And I had that. That's the reason why the project is called libhal. It is saying that we are the de facto library for hardware abstraction layer code for being portable in C++. And although I love that energy, I had to change up a little bit here because I think I was getting a little crazy. I realized that if I was going to make a libhal-linux, calling it liblinux is going to put me under fire because it's going to be, wait, hold on. Why is your liblinux have nothing to do with actually Linux? It has to do with like user space stuff, not like deeper APIs and that kind of thing. So yeah, that's why we made a repo name change. Next up, we have packaging up the linker scripts. Linker scripts are now packaged into processor and target libraries. You no longer need to copy the standard linker scripts from the library repos for your project. As an example, we're going to go back to this real quick. Where is it? Yeah. There is no linker script here. And yeah, I'll go into this a little bit. But yeah, there's no linker script here. I was able to eliminate the need for you to have to package it yourself. And I was able to package it within the actual, libraries. And it's really cool because you can actually use this in order to extend things. It's like how you can depend on other C++ headers and then extend them and do things that way. You can do the same thing with linker scripts. For example, the libarm Cortex Conan recipe adds the path to the linker script to the list of linker flags, enabling other linker scripts to include it and extend it. This then made taking the ARM common linker script and extending it so you don't always have to keep it where you are. All you need to do is, include it, literally in boldface, include, and I'll show you what that looks like in a sec. Actually, no, I can show you that right now. Yeah, let's show you what that looks like. It's nice and short. That's why I love it so much. Let's go LPC. And where are my linkers? Here we go. Yeah, include libhal ARM Cortex /standard. Done. All I gotta do is set a couple variables, where my flash starts, how big it is, where my RAM starts, how big it is, and how much I want to keep for stack. Therefore, the heap could not exceed that amount. Then include the standard library and the standard linker, and it will fill out the rest, and then you're done. That's the beauty of having the standard linker. I'm going to make a couple other ones because there is another RAM block that's available for, I think, a couple of the LPCs, and I want to make those available. So I might make one that does standard 2 RAM or 2 flash. But yeah, so that's kind of the cool thing. That's the kind of the ability that you get with adding the linker path to your linker flags. It allows you to compose and extend and include other linker scripts for whatever purposes you may need. And I just showed you what that looked like in lib LPC40XX. And then also, actually, the other thing to add here is that let's say you wanted to use one of these in your section for. Actually, it's removed. That's good. There's a way to add linker flags. I believe it's target link options, and you can put all your link options in here. Let's say I did something like this. You could then put in -t libhal LPC40XX /LPC4074 LD. That way, you can just grab which one you need. And then you can also use your own linker script. If you have a particular linker script, a custom one that does some extra work that you want it to do, fantastic, good on you, cool. This particular scheme does not cause you. Sorry, I have a yawn. This particular scheme does not prevent you from using your own linker script. It just provides it to you. It makes it available on your path if you ever want to use it. Next up, we have removing the need to install the toolchain. I am so happy with this change. So a lot of this entire presentation is just going to be about how annoying everything was previously and how to fix that. This really just comes down to, I show the robotics team how, here's how you do things. Then they try and they get stumped. And it's not their fault. It's literally because the things weren't as clean and as simple to get done. So we had to fix those things so that things were as smooth as possible to get started. As I feel like I demonstrated with the thing in the beginning. So, installing and explaining how to install the GNU ARM embedded toolchain is annoying, changes often, and can trip up inexperienced people. Here are just a couple of items that we had to deal with. apt-get used to be the method of installing it for Linux, but they deprecated it. So you literally, if you try to do apt-get install ARM-GCC, currently from their PPA, I think it only goes up to 10 and stops there. For Ubuntu, if you look at their version, it goes up to 10, and someone else is putting up 12 for the bleeding edge version of Ubuntu that's not even out yet. So if you want that version of Ubuntu, you got to download it yourself, got to put it in your own path. But the second item literally talks about how inexperienced people are going to struggle with setting up their path and doing it correctly. And it gets even worse if you have, for some reason, multiple compilers on your machine. Then the paths get confused, and you don't know which one you're using. It's a disaster. Brew for Mac is fantastic. It almost always has the right stuff, but it may not always be up to date. We have to depend on someone else to do that. We could probably also upload it ourselves, but honestly, we can eliminate the need to depend on a whole slew of other package managers to manage their packages. That would be better, especially if you have one place to put it, and that's what we did. And the last one is easier for developers to forget setting the path for Windows installer program. The Windows installation process for an inexperienced user is probably the simplest. No command line required. You download the exe. It opens up an installer. You click all the way through. At the end, there's a little square checkbox that says add to your path. If you forget to do that, libhal will not work because it doesn't know where your compilers are, or the ARM cross compiler won't work because it won't be able to find it. And this is only just the tip of the iceberg. There's so many other things that have come up when it comes to trying to install this thing that are just is a burden. So the fix is this: GNU ARM embedded toolchain, the Conan tool package and repo. If we click on this right here, it's a really simple repository. It has a Conan file, a README, a gitignore, a test folder, which I think I might even be able to delete because I don't know if that's even that useful. No, it's kind of useful. Having that there is useful. And some workflows, and that's pretty much it. This one here explains to you how to use it. You basically do tools required, so not requires as if it's a dependency, like a software dependency. We do tools required in order to download and install this particular package. So the binaries are available for you. Oh, and yeah, that's pretty much it. And if you look over here, you see this release, ARMGCC 11.3. I basically put down all the versions of ARMGCC that we'd ever use. Version for Linux using on ARM, so that means you could technically compile libhal on Raspberry Pi, which wasn't actually possible before with SJCDev2. I don't even remember if they had a version of the ARM embedded toolchain for ARM-based Linux. But beside the point, we have that there. We have x86 for Linux. Then we have Mac OS, and then we have Windows. So we're just going to be using Git releases in order to store all of our cross compilers. And then we'll have this particular Conan file, a different Conan toolchain file, basically per. I might have to actually rename this from Conan file to Conan file 11.3. just to separate them out, because this will handle installing 11.3, and we'll have another one for installing 12.2, I think that's the latest one, 12.2. And then, keep adding in more and more as time goes on. Let's zoom back out while I do that. Okay. And yeah, it installs everything inside your .conan directory. It doesn't add anything into the path. There's some clever ways to add that stuff back into your path, but if you don't really need to, or don't really have any reason to call the commands outside of Conan, then you don't need to. But yeah, all the bin stuff is added to your path when you try to compile with CMake, and that makes it so that you don't have to actually, globally install it. Next up, we have finding a place for the toolchain CMake file. Just like the linker scripts, having to copy the toolchain CMake file from target or processor libraries is is unacceptable annoyance. Yeah. Okay, that was right. The solution is to do a similar thing we did for the cross compiler, making a tool package that is CMake ARM embedded, and it holds the CMake helper files and holds the toolchain CMake. Said CMake a lot in that sentence, or in that whole slide. The whole thing here is that this particular file, this particular Conan package, simply just copies the license and the toolchain CMake and puts inside the package directory. That's pretty much it. And then adds the toolchain to the user toolchain. I may consider this is CMake ARM embedded. I meant to say that actually, yeah. So it's not, yeah. So I may end up having separate packages, one that includes the toolchain and one that includes helper functions for toolchain type things, but we shall see. I think for now this seems pretty clean and pretty simple. I don't know if we're going to be adding that much to this, but who knows what users may want in the future. But yeah, this allows us to basically copy this little toolchain file here, which specifies, to CMake how to use the ARM toolchain and provides additional functionality so that we can present size information or build our hex binary files and disassembly files, all that stuff. So that is the CMake ARM embedded package. Now, next up, we have using target library components. So there's another annoyance that has been a thing, and that is to remember the architecture processor, the architecture/processor, and the correct linker scripts. So actually, I meant to. This has been a mistake on my part. It's not just remembering the architecture and process that you're using, but also specifically remembering the flags you need for your compiler. Yet another thing that the user has to remember and could have made a mistake on. With components, a single library can become multiple, and therefore libhal LPC40XX is the first one to be split up into components, and that provides you with LPC40X 88, 78, 76, 74, 72, and XX. I'll show you what that looks like in a sec, but basically the one at the bottom I want to talk about, if you ever use the LPC40XX, it's a special target that does not include the architecture flags or linker flags. Why is that important? Well, if you want to run unit tests with that package, you want to use it as its own package, or if you want to inject your own toolchain, inject your own architecture flags, or your own linker flags, or your own linker script, basically, you need to use the LPC40XX in order to disable all of that. Now, previously for CMake link libraries, we had libhal LPC40XX, libhal LPC40XX. That's a bit of a mouthful and kind of redundant. This is how CMake usually does things. That's the default. But I decided that we should change it up to be libhal LPC40 and then whatever the name of your particular chip is. If you use the explicit name and not XX, it will set up the compiler commands and the linker script for you. And that explains the reason why, if you look over here, why the CMake file we have here does not include the typical thing it doesn't include any of the architecture flags. It also does not include any of the linker scripts here. All that stuff's been eliminated. It's all handled for you in the background. No need for you to worry about it. Which, if anything, makes this thing even more portable. The only thing that's not portable here is this ARM Cortex post build. Otherwise, if you decided not to use Conan and somehow are able to get all the dependencies down for libhal LPC40XX, and that thing created a component that gave you this, that would pretty much be, that's square up. So yeah, there's that. Next up, we have a couple of updates to the documentation. So we got a couple of things here I want to show you. One of these is architecture design A17, A18. I did show you the change here just because it's easy to find here, but I'm actually going to go to the documentation to show you what it really looks like. Let's go down to 17. Wait a minute. Was it 1718? Oh, 1718. Okay. Well, yep. Oh, my goodness. There should be a 19. A little typo here. I got to go back and change that up. Milo, if you're on the call, can you add a little note or make an issue for changing this to 19? And I think there was one other mistake that was made here. I think it was lib LPC in the trying out libhal. But yeah, going back. So yeah, so we have 3 new items actually here. Number 1 is always return. Oh, actually, I don't know. I think I just meant 18 and 19 in this case. But actually, I don't know if I went over this before. This one's not super important. You can read this on your own time. These 2 items here pretty much just discuss the details of how callback and why we used the inline function over stood function and over function ref. And then here it goes into why we sized it to basically contain 2 pointers and just 2 pointers. So yeah, so that is that. Next up, we have the README for lib LPC40XX. I'm really liking where it's going. Here you can see your setup, your software APIs, your setup stuff. Basically tells you how to set things up, how to build the demos, how to debug. I'm sorry, how to make a debug build, how to make a release build, how to flash. So all that information's here. If you ever forget it, you can always come back to this in order to get the information. How to use JTAG, how to flash over JTAG using PyOCD. And then if you scroll to the bottom, we actually have a section for on-chip software debugging, which is not complete yet. Well, the part for PyOCD is pretty much just this. 2 commands and you're done. This one here I'll get into later. I don't even know if I'll even write this out because I'm more in favor of PyOCD. OpenOCD is great because it works for almost everything. PyOCD only works for ARM stuff, but still. If we go back up here, we will see that we have some new guidelines on how to, well, basically add libhal LPC40XX to your project. So what you have to do to your Conan file, recommendations for your tools requires, how to use CMake, what targets you have available to you, and then adding in the ARM Cortex post build, which builds all of your hex, binary, and disassembly files. It also goes into explaining how to actually initialize the device, such as first thing you got to do is basically set up your data section. Next up after that, you need to initialize your floating point unit. And then if you want to set up speed, you have this. And then I have more things I want to add in, such as details about how to do clock control. I'm not going to probably detail everything about it, but just how to grab the clock control object, what things you can modify in order to change the speed, and then pointing into the API so you can get the full explanation. It basically looks like this. If I go to, well, I'll just go here actually for files and go system controller. And if I can find clock configuration, yeah, it explains all these different things, such as, EMC, half CPU divider, oscillator frequency, set the frequency of the input oscillator, defines a peripheral clock divider amount, that kind of stuff. A libhal starter just gives you the starting information on how to run things. That's it. Nothing too crazy. And then there's another style guide edition, which is some information on how to integrate third-party libraries. You should almost always try to not do that. That's pretty much the majority of the first paragraph here. But in rare cases where the best solution is to integrate it directly in line inside the actual code, assuming that the license is compatible, then I explain here how to do that. And then this is pretty much the last slide for this week's libhal meeting, but it just shows you the standard project dependency tree. So here we have all of our software that's in green. Libhal is, or liblpc, or a project depends on libhal LPC, and that depends on libhal ARM Cortex, its processor, and that depends on libhal. And this whole little chain gets you this, but you only need to include libhal LPC. It includes all the other ones transitively. Same thing with GNU ARM embedded toolchain, and same thing with CMake ARM toolchain, just to make our lives a little easier. And that's pretty much it. And I just have to say that after last 3 weeks of really grinding on this has made me very excited about the project. I really like the fact that setup is around about 7 minutes with me kind of, talking through the whole process and even switching over to other things. I really enjoy the fact that things are starting to look pretty simple, and it's all within the Conan ecosystem. There's nothing here that I feel I cheesed. There's nothing here that I feel is a bit of a gross cop-out or a gross solution, an ugly solution to something. Like, for example, I could have made the CMake ARM toolchain just be a file that's in the ARM repo or libhal ARM Cortex repo, and then used fetch content in order to grab the CMake file. I felt that was too outside. I mean, that could work. That's fine. It's just I didn't like the idea of going outside of the Conan fold just for that, and then having to deal with fetching stuff, because I didn't like the idea of, if you don't have internet but you have everything cached in Conan, you should be able to use everything. So that's all to say that I feel like where the things are at with how the infrastructure is, how things are at when it comes to the documentation, how things are at when it comes to the setup instructions, and how the code kind of works, how everything kind of just works in general. A lot of the ideas that we have, I think all of this is really starting to come together, and I'm in a really comfortable spot we're not at beta level yet. I want to get a couple more things ready before we hit beta. Specifically, like I said before, I want to clearly demonstrate and show taking a single program that's rather complex and moving it from one chip to a very different chip, maybe the same, maybe similar processor, but to a different chip, and have the code work pretty much exactly the same. It's going to require some help from the robotics team. It's going to require, me and Milo have already put in the effort to build up the LPC micromod board and also the STM micromod board. If we can show that working on the LPC, the STM micromod board, the GV32 board, which is a clone of the STM board but using RISC-V, and a Raspberry Pi or just any other single board computer, and have them all be running the same exact program, just with slightly different link libraries, effectively. I think that will show the strong power of libhal. And that is when we are clearly in the spot to go to beta, to get it out there so people can see it and we can start getting the world interested in it. And I think that is pretty much it for today.